Hello everyone, my name is Shambhavi. Hope you all are doing well. So in the previous video, we had taken one question and we had just basically solved this question, right? We had just had one question and we had just done the things and seen the procedure that how to find the confidence interval and even solve that question, right? So just let me quickly show you that question here, right? And even let me just zoom in so that it is properly visible. And yeah, here it is okay, right? Now, basically, this was a question that we had taken that suppose scores on exams in statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. Actually, basically, in this question, we were given the mean, we were given the standard deviation, and even we were given the sample size, right? We simply need to find out the confidence interval. So, for the finding that we had previously seen the steps, so we had just done that thing here, okay? Now, here actually what we had done, we had taken the confidence interval as 90%, right? We had just taken the confidence interval as 90%. Now, if I just want to change this confidence interval, then what will happen? Right, then basically will there be some effect on the answer, or basically will there be any effect on the area or something like that? Will something happen or not, right? So basically today we are going to see that if I change the confidence level or sample size, then what will happen? Right, so just let me quickly put the heading here. And yeah, here I would just take one marker. Okay. Now just I would just ask you to listen to me very carefully because here basically we are going to move one step more further in this confidence interval topic. Right, so I would just put my topic here, and that is basically the name for that topic which we are going to discuss today is changing the confidence level or sample size. Okay, so this is basically the topic which we are going to go today, that is changing the confidence level or sample size. So for this I already have one question for you, so let me quickly show you that question here. Fine. Now the question actually says to me that suppose we change the original problem by using a 95 confidence interval. So my question says here is that find the 95 confidence interval for the true population mean statistics exam score, right? So previously we had actually solved the 90%, right? We had actually seen that how to solve the 90% confidence interval. Now if I just change that confidence interval from 90 to 95%, then what will happen here? Right, so here I would just start solving the things for now, and let's see that basically at what final answer we just come here, right? Okay, so I would just start writing here to find the confidence interval. I would just write the short form for confidence interval, that is CI. Okay, to find the CI, I would just write here you need the sample mean. Okay, now firstly here I'm just writing all the things that we just simply need to find the confidence interval, right? We just need the sample mean, that is x bar, and the error bound mean, right? You remember the EBM, this one, right? So we basically need these two things only for finding the confidence interval. If we are having these two these two answers and these two values with us, so we can easily just find out the confidence interval, right? Because it is x bar, so like the formula for that is x bar minus EBM comma x bar plus EBM. So here x bar is actually the mean and EBM is the error bound mean, right? This is the format for which we use for finding the confidence interval, right? So if we are having only these two things, so we will be able to find out the confidence interval, that what is the confidence interval. So in our case, we know x bar, so that is 68, right? Above we had seen the question that basically the x bar was 68, right? Now we even know the EBM, right? So the formula for finding out the EBM is Z alpha by 2. Z alpha by 2, alpha by 2 will be in the denominator for Z, right? And this is multiplied by, okay, just one second, yeah, multiplied by sigma upon under root of n. So sigma is basically my standard deviation and n is basically my sample size, right? These things we had already discussed in the previous video, so I hope you all remember these things very clearly. Fine. Now, so here I am given my sigma also, so that is basically 3, right? And the value for n is also given, and that is 36. Fine. Now, here I just want to find out the confidence interval for the 95%, right? So if I just like convert that into the point, so that will just come here. So I would just write here the confidence level, okay? The confidence level is, and here I would just write 95%, and in the bracket it would be CL is equal to 0.95. Right, so CL is equal to 0.95. This is the value which you just come here. The confidence level is 95% and CL is equal to 0.95. Fine. Now, I just got the value for CL and that is 0.95. So now which basically which format or which relation I can just apply here. So I hope you just like remember the relation which we have used in the previous video, and that was alpha is equal to 1 minus CL, right? You remember that this was one of the relations which we are having between the alpha and the confidence level, right? So here I will be applying the same. So from here I can just get the value for alpha. So alpha is equal to 1 minus 0.95. Okay, so the value for alpha will come out from here as 0.05, right? So for finding the EBM, I just got the value for alpha also, okay? That is 0.05. Now, if I just want to find out the alpha by 2, because in Z in denominator that is alpha by 2, right? So I would just write alpha by 2 is equal to 0.05 divided by 2. Right, so when you're just going to do the division of this, so you will be getting the answer as 0.025. Just like divide it all on your own, fine? So that is 0.025. So I know the value for alpha, that is 0.05. I know the value for alpha by 2, that is 0.025. I know the mean, that was obviously given to us in the question, right? Now if I just want to write it in the form of the z, right? So how would I be just doing that thing? So here I would just write z of alpha by 2. Just let me quickly come a little bit here, right? Z of alpha by 2 will be equal to Z of, and in the denominator it would be 0.025, right? So Z of alpha by 2 is equal to Z of 0.025. So from here I can just say this thing, right? Now what is the next step that we need to find is that we need to find out the area to the right and to the left. So to the right we had already got the area. Now is the turn for finding towards the left of the area, right? So what I would just do, I would just come down here. Right, let's start writing the things. So here I'll be writing the area to the right of z of 0.025 is 0.025, right? 0.025, and the area to the left of z of 0.025 is 1 minus 0.025, right? We basically like subtract it from 1, and whatever the answer we just get, that will be the area for the left, right? So that is here 0.975. Fine. So this is basically the area to the right of z of 0.25, z of 0.025 is 0.025, and the area to the left of z 0.025 is basically 0.975, right? So this is the value which we had just got here for the area. Fine. So now here I can just calculate the things. So z of alpha by 2 is basically z of here 0.025, and that will be resulting as the output in 1.96. Right, and if I just want to now find out the error bound mean, so now that will be very simple because we know all the values. So the value for z.025 is 1.96. I would just keep it here, and I would just like multiply it by first one was the sigma, right? Above we had just write the sigma, and under the here in the denominator we just simply needed to write the sample mean. So that is under root 36. So after calculating it, you will be getting the final answer as 0.98. Okay, this is the step after when you will solve it. You will be getting the final answer as 0.98. Now, moving towards the format, so that was x bar minus EBM, right? So x bar we were having the value for x bar as 68, and the value for EBM is 0.98 that we have recently found out, right? So after the subtraction of both of these values, I'm just going to get the output as 67.02. 67.02. Right. This is the value which I'll be getting for x bar minus EBM. Right. And what about the x bar plus EBM? So x bar plus EBM, is equal to 68 plus 0.98, and that would be 68.98. Right. Now let's go above for a while and see out that is there any difference in the x minus EBM and x plus EBM values. So my values are here, right? So when we had taken the 90% confidence interval, okay, so in that case, I was having the x bar minus EBM value as 67.17. Fine. Now when I have just taken it as 95%, now I am having the value as 67.02, that is for x bar minus EBM. And when I have taken the 95% for x bar plus EBM, I am having 68.98. And when I have taken the value x bar plus EBM for the 90%, then I was having 68.82. Right? So yes, there is a difference in the value. Let me just quickly write the final estimation as we just write, and then let's see that what are the things, other things. Okay. So just let me write that. Here I would be just writing that we estimate, right? You remember the sentence which I just gave you in the previous videos. We estimate with 95%, we estimate with 95% confidence that the true population, I would just write a short form for population, okay? We estimate with 95% confidence that the true population mean for all statistics, exam scores is between, and just let me really calm down, and here I would just write exam scores is between. Now what was the interval that we were getting? The interval was, okay, I would just remove this bracket, no need of this. So interval was 67.02 and 68, okay, 68.98. This was the interval that we were getting. So that was basically 67.02 and 68.98. Okay, so this is the final estimation that we have got. Now from here what we can just conclude, why I have just like found out the 95% confidence interval also in this one. Okay, why I have just done that. So just let me take a different color so that I can just write the things for here. Fine, just let me calm down. Here, yeah, here. Now, let's compare the 90% and 95% confidence interval, okay? The 90% confidence, the 90% confidence interval. Now, what was the value for the 90% confidence interval? So, I remember, so that was something about 67.18 and it was 68.82, right? So, I remember that thing. So, the 90% confidence interval is this much, right? So, this is the first thing. Now, what talking about the 95% interval? The 95% confidence, the 95% confidence interval is, now what is 95% confidence interval? So that is 67.02 comma 68.98. okay, this is the 95% confidence interval, right? Now actually from here what we can just say is that from here we can just say that 95% confidence interval is wider as, okay, just let me quickly write here, is wider as 0.95, as 0.95 area is larger than 0.90. Yes, that in mathematics, basically in mathematics, this is very true that 0.95 is greater than 0.90, right? So the 95% confidence interval is actually having the 0.95 area, right? And the 90% confidence interval is having the area as 0.90. So 0.95 is bigger, right? So that means the 95% confidence interval is wider. That means it is basically wider than the 90% confidence interval. So let me go to that place where we had just found out the area. We have written it somewhere. Right, so here we had just used that thing, that is 0.95, right? Here also we had just used that, and in above one, the previous one, it was here. Yeah, here basically this one, right? Here we had just used. right? So this is basically how you can just say and how you can just find out the difference between the 90% confidence and a 95% confidence. So from here you can just say that in both of these, so 95% confidence interval is wider because it has a larger area than the 90% confidence interval, right? So I hope now you just got the point that basically first thing which you can just like learn from this video is that how you can just find out the confidence interval one more time, right? Second thing is that if you just change the value for the confidence interval, then what will be the effect on the final answer which you are gonna get, right? So this is all for this video. Till then, thank you and take care.